Okay, guys, I think we waited long enough, so we'll start the presentation now. Hope you guys are all well. I encourage everybody to ask questions. Anything that you want to ask, just pop them onto the Q&A part of the slides. I'm going to basically be focusing on the fire side of safety side of the PV installation, because that's become a major thing over the last few sort of months. Myself, I'm Suki Mataru. I've been in the PV industry for the last since 2008, so pretty early start in the UK when it was just actually hitting the bell curve and accelerating. Just before the feed-in tariffs were introduced into this country, I primarily focused on the inverter side of the business rather than the whole spectrum. But obviously, over time, you get to learn about how the panels really behave, etc., what kind of dangers they cause, etc. So I'm quite involved in that as well. And I am pretty astute with the battery storage side of the business as well. So across the spectrum right now. So we'll focus on, as I said, on the fire side of things and look at the causes of what causes fire in PVs. The main reason for cause of a hazardous situation in a PV installation is the high DC voltage arcing. And this is obviously due to, as the voltage gets higher and higher across the string, the whole system risk actually amplifies. The higher the DC voltage, the more amplification there is across the board, whether it's a small problem, a problem that normally a 40-50 volt DC will not really be bothered with. The resistance wouldn't be that high at that level. But as the voltage gets higher, that small problem becomes a big problem. It's like a leaky bucket in any situation where if you've got tiny water pressure coming through, it just drips along. You don't really notice that drip. But if the pressure gets very, very high, you might have a pipe burst, and that leak becomes a major problem. It's exactly the same with electrical installations. As the voltage gets higher and higher and higher, the problems get bigger and bigger and bigger. So we will obviously try and mitigate this. As is the main reason is the high voltage in the strings, and usually the strings are the problem. As you actually get, sort of 5, 10, 15 panels across, the voltage gets higher and higher. And we actually then get to a situation where we need to manage that DC. Majority of the problems in any installation are due to DC. And these, as 77% of the research that's shown on sites is that the DC distribution management is a problem. And we need to obviously try and avoid that as much as we can. And it's quite easy to do that in domestic systems. We'll go through that a little bit more later on. As the strings get bigger and bigger, there are more point of failures. So we need to avoid those as well. As by see, okay, how can we mitigate more and more DC connections across the board? And then obviously heat buildup. Heat buildup becomes a bigger issue. Here we go. A typical situation. A picture that shows you various situations, which we'll go through over the next few slides. One of the main reasons that we find in a lot of systems, not so much in a domestic system, because as we haven't got a high voltage, high DC voltage going through the strings, we don't tend to sort of have this as a problem, but it is still a drip in the system, which could become a bigger problem over time. And to avoid that, we need to obviously make sure that the matching of connectors, any badly crimped MC4s should be looked at and rectified wherever possible. And obviously try and avoid any water ingression into the connectors. You can see the connector on the right-hand side here. It's got a slight micro crack in there. So, and that crack becomes a problem for water ingression. And you probably get water ingression going into that. And eventually at a point that could become an issue. Again, as I said, higher the DC, the worse that problem will be. And we need to avoid that at every cost possible. Crimping on site is a big issue. Mismatches are a big issue, as you can see from that little thermal image. An eye won't be able to see that there's a hotspot there and a hotspot higher. So, for example, if you suddenly get 800 volts or 600 volts DC going through that, which could easily happen in a commercial site, that could become a problematic issue. So we need to avoid that wherever possible. We also, the faulty isolators. In the UK, we tend to see a lot of isolator issues, primarily, again, this is again due to the bad crimping, bad workmanship majority of the time, but there are times when you've got a faulty isolator as well, and that could cause an issue and a burnout. The power termination is also a big issue where people just don't terminate the power well enough. The hotspots. You need to avoid that at every cost. So trying to be a little bit more meticulous at the first instance and get it right is very important. So making sure that these little mistakes are not overlooked at all. And you've got to bear in mind that this is high voltage DC coming to the house, property, and consumers could be, nearby as well. And they could be easily, get electric shock if they unfortunately tend to touch something that shouldn't be touched at the right time or the wrong time. So we've got to make sure that the isolators are sorted out. The other thing which a lot of people overlook is the damaged and faulty panels. This is the picture on the left is a picture of a panel that has the back sheet has been scratched during installation, and obviously nobody's really going to take care of that. They're going to simply, they're going to simply hide those away. Sorry, bear with me a second. Okay, go back to that one. And people overlook these. They will simply install these panels onto the site and not worry about it. But that is a hazardous problem issue. Again, in a sort of a long string system, that could become a big problem. Water is going to get through there. It's going to short circuit. Resistance is going to build up. That is going to bring a lot of thermal activities, obviously, heat a real big hotspot, and that hotspot could get pretty dangerous. And usually, a lot of the instances when this happens on a commercial site, when you see panels half burnt, are basically due to a problem that has occurred on the back sheet, and the water has just got into the system. The junction box does not always perfect. So you might get a junction box that is faulty as well. Again, a junction box will probably not notice a problem when we're handling 100, 200 volt DC. But again, when we get to 800 volts, we're gonna bound to see that happening. Right. The other problem, obviously, is cable exposures. The cable, a lot of people don't realize that, that's going to carry the power, right? Power is being carried by the cable, and the cable, I get a lot of questions. How long is the panel or a inverter warranty? And, usually, obviously, everybody wants 25-year warranties, 15-year warranties. Nobody actually asks about the cable, what kind of cable warranty is. A typical warranty on a cable is only 10 years. And that's one of the crucial parts of the system. And a lot of people just overlook it, don't really protect the cable much, and you're going to end up in situations where the cable is rubbing against sharp edges. Cable expands and shrinks as it heats and cools. During the daytime, it's going to heat up, it's going to carry power, it might be hot, the ambient part, temperature could be pretty high. That cable is going to slightly expand. And at nighttime, it could suddenly be freezing cold, and that cable is going to shrink slightly. And it's going to, over time, rub across a conduit or something else. People have to make sure that that rubbing doesn't happen and cables don't get exposed. If they do, then obviously the become a fire hazard. An arc can easily get formed, and that arc could be dangerous enough and have enough energy to ignite things around it, even melt things around it. We can see also, obviously, chewed by pets. The cables, exposed cables again get very easily chewed by pets, and then they can cause damage as well. And then we get hot spots. Again, some people overlook this problem. Shading at a consistent, over consistent time is going to cause a panel to start creating a hotspot, a permanent hotspot. And that over time is going to cause a problem to the panel, of the whole system. And that could obviously lead to hazardous situation. And then we go, obviously, a situation where you might have panels being damaged, walked on, hail damage, etc. And they're going to cause hotspots as well. And these hotspots can get dangerous, high voltage. Again, something that should, if anybody's doing O&M, should go out and make sure that these are, rectified. If a permanent shading situation is there, use optimizers, or as I'm talking about, use microinverters. So I'm going to go through a little article that was published only 4 days ago. Microsoft covered it. It was written by an English newspaper called Telegraph, and they covered up a fire that happened in August in a lady's house. And their title is obviously Fears on Solar Panel Safety, as numbers of fires, have risen by sixfold. That is quite obvious. And this is a video photograph, just a still part of the video photograph she took. There's a hole in her roof, which her son called while he was at home, saying the house is on fire, which she rushed back, and the panels are on fire. The cause of fire, I don't know as yet, but I'm sure is obviously one of those causes we thought. So the number of fires in solar panels has really soared over that's independent, obviously, something else that has happened. And in UK, we've already seen that increase sharply. Already have 66 back in July. I'm sure there's a lot more, including this one that happened in August. And they're only going to go and rise. The issue is that the older the systems there are, the higher the problem is going to be. We've got over 1 million installations in UK on the domestic side, and some 700,000 are pre sort of fit and of pre sort of feed-in tariff. So we got 700,000 systems out at least, 10 years old. So and those systems are going to have some problems where thermal activities resistance is building up in the systems. So we will probably see the fires go up over time. There's a fire inspector called Captain Richard Burt, who goes on has founded an organization called Solar and Fire Education, SAFE in other words. And he's obviously goes around the US talking to people, and I think he's done a few talks in this country as well, professing that obviously the technology has to be changed in order to avoid these fires. So he's obviously, this is his statement saying the typical traditional sort of panel situation generates high voltage electricity of up to 600 volts DC. So that usually wouldn't happen today in most of the domestic strings, but it could easily happen in rooftop commercial systems. And rooftop commercial systems are as we need to obviously avoid fire in those situations as well. The main causes of fire, obviously, such high voltages are extremely prone to harm. That's the problem. Again, common causes of fire without a doubt. But that's his statement again. He said if you make the wrong connection, then the honeymoon period is over. Obviously, he's exaggerating. All the panels are going, all the systems are going to go that hot, but obviously we have a lot of concern out there at this moment. So he's obviously said, however, microinverters can be connected to convert the output to a safer 230 volt DC. And it is vital the UK adapts this technology. And I think so. The time has come when we do look at technologies and go to safer sort of equipment. And there's obviously, with microinverters, safety is very, very, very high because we don't handle DC at any other level than at the panel level. We'll go more through that later on. And he's obviously recommending that all homeowners start retrofitting microinverters onto their systems. It is an expense, obviously, for people to go out there and change, but there are lots of reasons why I think this practice should be adapted going forward. Right, why choose microinverters? Going on to the real reason why I think this webinar is taking place. Microinverters convert DC at the panel level. So the DC does never go higher than what the panel is going to generate, what the VOC of the panel is. So if the panel's VOC is, say, 30, 40 volts, it's going to stay at that level. And that's a drip. It's not a danger. It's most instances, it's not going to have enough resistance to build that thermal activity to melt any connectors or to really ignite anything. So if there is a problem in the connector or elsewhere on the panel, there's a hotspot, etc., that's not going to get to a dangerous level because we are keeping the DC at a very, very low level. We're not going to allow that thermal activity to actually exist because we are avoiding all that resistance that high voltage would do. So it's fundamental to look at that in that way. So converting that straight from the back, we've got multiple advantages. We'll go through that slides, but the main reason is that okay, we're going to make it safer. We're going to keep it at as low level as possible. We obviously have decentralized power optimization as well. So here we can actually no matter what's happening with the sort of shading side of things or other elements that might bring the performance down, we are more or less going to keep that going. So in this, in this instance, for example, if there is a shade coming in, the microinverter will handle that shade. It could be also a hotspot. It could be a micro crack on the panel. It could be a bird, worming, spoiling the panel. It could be anything. So that brings in some kind of resistance in that panel's productivity. So we will be able to, just like any optimizer, because every panel will have its own MPPT. So we will be tracking the IV curve for that particular panel rather than tracking an IV curve across the string. And as we know, the string IV curve then gets affected by the weakest panel in the whole system. And if the panel is generating only 80% of the generation, that IV curve across the string is going to affect all the panels, and all the panels are going to be degraded in the performance. So that's very important. And we can also bring in panel level monitoring, so, which is also crucial. At times you need to know what panels are performing and what panels are going to cause a problem within the system. It is essential that we, sort of look at those panels, and if the panel is suddenly performing badly, then we need to address that as soon as possible. Microinverters also give you the flexibility of design. Flexible, i.e., panels don't have to be facing in the same direction. The radiation could be anywhere, could be facing northeast, west, because they all individually have their own MPPT. So we'll be tracking their IV curve no matter which direction they are in, rather than relying on a string. So IV curve. It doesn't matter what type of panel is. So in 10 years' time, so the panel fails and there's some other issues with the panel, you could easily remove the panel off and replace it with any panel that will fit in within the microinverter's specifications. And you'll be always be able to find something out there that will fit that specification. So that gives you a strong flexibility using a microinverter going forward. And if you need to add a panel or add panels to the system, very easy. You don't need to reconfigure the whole thing. You don't need to go and buy a new string inverter, for example, or restring the whole system. Just add panels as and when you want them. So very, very basically easy system. And we obviously harvest the energy, we optimize it. And in a typical system, the worst case scenario I've seen is around 5% increase in the system's generation. And we can go up to 20%, depending on how much shading there is, how much other issues there are, snow, rain, water drops, etc., dirt, bird crap, that kind of stuff. Sorry to use that word. But, those are all sort of available. Those functions and features available to us to increase the harvest. And obviously microinverters, because we're not pushing the components of the microinverters as well. We're not running them at 300-400 volts and then converting them down to 30 AC, where a lot of activities are going on to do that conversion. We more or less sort of work at a very low, again, at the panel level voltage. So the components are not being pushed very hard. They're not, because the components are not being pushed too hard, they obviously have a longer lifetime. You can actually give a long warranty on these products. It's like a mobile phone. I mean, most of the time you buy a mobile phone, it lasts you for years. The only issue that will ever happen with a mobile phone is its battery. Majority of the time, everything else will work, and it's doing a lot of things. That mobile phone is a camera, it's a sat nav, it's sort of a video system, telephone, the whole lot. So there's a lot of electronics obviously crammed into it, but they hardly ever go wrong because they're running at very exactly with microinverters, we run at very low power rating, and that means we are not really pushing these components to an extreme. So that gives us a better lifetime. And it's also simplified. It's you don't really need to run string diagrams to really, and sometimes when you do this string diagrams, you still get the stringing wrong on site, especially for commercial rooftops. You might get a stringing that there's so many cables coming in, and you just sometimes, if you don't label them right, etc., you're bound to get some issues across. So you got to be very, very, very careful when stringing panels on a normal string inverter. Labeling, lengths, loss of power over the length of the cable, etc. We don't need to worry about all those. We don't also need to worry about the isolation. We don't need to worry about the impedance, which obviously with the other inverters you have to. And you don't really need to worry about the placement of the inverters. Usually with a string inverter, where do I put my string inverter? And that becomes an issue. So the microinverters is very, very easy. Basically, with our systems, we can actually, and I'll go through the microinverters in a minute. We can have microinverters that can have 8 panels per microinverter, and I'll go through those later on. That brings the costing down, but obviously makes life easier for some of the commercial systems. Our portfolio is quite long, but we're going to basically focus in this country. We'll focus on range, and I'll go through that portfolio. Right. Obviously this tells us the efficiency, so no single point of failure. Again, this is the advantage, of a microinverter. If a panel fails, you're not dragging the whole system down, and if one inverter fails, a microinverter, you're not dragging the whole system down either. So point of failures, we reduce those quite a lot. Right. The range we have the top of the range is what we call a Titanic. T-Sun is the only company to do an MP3000 product, which goes, takes the bigger panels and generates 3 kilowatts of power. The MP3000 can take 6 panels, and those 6 panels can be up to 700 volts each. So every panel has its own MPPT. So no need to worry about all kinds of issues that a normal string inverter brings in. The next is the MP2250, which is a 4-panel system. And again, 4 MPPTs, very simple to use. And the final in the Titanic series is the MS3000. The S obviously stands for serial. It has 4 MPPTs, but each MPPT can handle 2 panels. So the voltage on the VOC on that can go up to 120 volts. So you can connect a couple of panels onto each MPPT. The reason we did that, obviously, cost in commercial rooftop situations, the cost can be quite high when you're using one of these. But again, if you're looking at optimizers like Tigo or SolarEdge, or if you're looking at other alternatives where you need fire protection, this is a lot more cheaper solution than those, even when taking the whole things into consideration. So the 8 panels on the last one, and price is pretty good. So that's the real spec, what the panel each microinverter can handle. So each one of those can handle 60 volts maximum on the lock. And obviously the current side, there's a correction on this. Where I think when you look at the MS3000, unfortunately I didn't spot that before. There's an error on that maximum input voltage. That should be 120. So we'll get that rectified and get the cost to you guys later on. So that shows you the MPPTs and the power rating that we can output. Obviously, the panels can be a lot more than 3 kilowatts. Panels, as you can see, with the MP225, we can have up to 700 volt panel. And then when the MP3000 and the MS3000, we can go up to 550. We are very particular on the component switches. I don't know why that slide's there, but it should have been, at the front. But it is where it is. But I'll quickly go through that. We actually are very stubborn in a way of choosing our components. We make sure the components choice is right, because obviously if you can't get it right from the offside, then it's not worth it. So we don't save pennies here and there. Try and go for the ultimate products that are available on the market. So our choice of component suppliers are the best in the world. They're really class. Right, back to the product portfolios. Right, and the next gen products we've got two MPPTs in one product, one MPPT, and then also full MPPT monitoring. So I'll go through all those now. Here we have the one with two MPPTs and one with one MPPT. So they range from 300. The single MPPT ranges from 300 to 400. So I believe we will probably be phasing out the 300 sooner or later, and then just also go to 400 and hopefully a 500 in the near future. So the ratings are going up, and specification again, these can handle modules all the way up to 550. So you can easily put some of the commercial panels onto it. So the only changes on these between these products is the maximum output on the microinverter. So 300 to 400 volts radio. Then the next is 2 MPPT product. So this one has exactly two of the previous products, two circuits. Each module is monitored on its own as well. So each panel can be monitored on its own, and obviously is managed on its own as well. So, but the reason why we do this obviously is to make it simpler, and the costing, because IP67 casing are not cheap. So when you actually put a sort of circuit into a casing that has to be watertight, etc., that casing element is quite expensive. So to bring that cost sort of down in a way per MPPT, we decided to put 2 MPPTs and 4 MPPTs into the unit. So this unit obviously is exactly the same, but 2 times the previous units we spoke about. And then we obviously go to the next lot, which is the 4 MPPT version of the product, and the 4 MPPT version. They're slightly different compared to the previous ones, but they will handle panels that are a lot bigger. So the MS1600 is readily available today. The MS2000 is being launched now. We'll be showing that at the show in October. So if you are coming to the Solar and Storage show October, in the middle of October, please pop by our stand and say hello. Right. The other products we do obviously is Easy Solar Kits. We call them ESKs for short. And these ESKs are plug-and-play systems, because we are converting the power at the panel level, so we can take our 1 MPPT or 2 MPPT products and put them on structures and plug them straight into a socket. No engineers needed. If you've got a socket available, literally put the panel wherever you want to put the panel, as long as it's obviously steady, and we supply the kits for that. We supply kits for the balcony. I'll play a little short video. Microinverters obviously make, sorry, I'll have to go back to the presentation. Sorry about that. Yeah, microinverters make it so much easier for us to sort of create systems like these plug-and-play systems. And this has opened a lot of market in a lot of different countries. Now these systems can be put on walls, put on balconies. Very, very simple indeed. They can go vertically. We got a product called a spider that can go on a wall angled or vertically. And so people have started using that as part of the facade. It can be easily used for fencing, etc. So this has opened a door to a market which was previously not sort of existent. And this boomed in Germany, especially at this moment, and I'm sure it'll boom other places as well, given time. As the panel prices are so low at this moment, there's no reason why this shouldn't really be going. But, sales should only increase. It can be done DIY. Obviously, in this country, DIY is not suggested for a couple of reasons. One is A, you might not have an outdoor socket. B is VAT. If you do a DIY system, you have to pay the VAT, which is 20%, quite a lot of money. So I'd rather pay a technician, £100 to come out and do it properly. It's not even an hour's job for most of the technicians to do this. And if they come and install it, they don't have to charge the VAT because it's installed by an installer. So it's a crazy rule, but that's the rule. The installer has to install the system not to avoid the VAT. I'm also getting clients now who are buying this system or inquiring about the system where they are going to install the battery into a house. But the battery on its own, they have to pay the VAT. But if they install one of these and the battery, then the whole system is VAT free. Crazy rule, but that's the way it goes. So the systems we have here, again, those are the spiders, called spiders because they are on the wall. This is the angled version. And we have a vertical version of these as well that sits flush onto the wall. People want that. And I see that everybody's taking part in that. I hope everybody takes part in this because there's no excuses for anybody now to take part in bringing some of the carbon down. Might not do much, but let's assume if we can get 1 million people using this, 1 million times 400 watts is 400 megawatts, right? And if we double that, that'd be great. Especially there's a lot of commercial sites around which have got a lot of walls that they don't use for anything. They can easily put one of these or the one that's totally vertical, flush against the wall. Use 4 of these. It will cost them very little money, and they're on board of saving a bit of this full plan. And we got the balcony systems. This is quite exciting. At this moment, we're bringing in a balcony system called the Air, which will have 2 200-watt panels, and because the packaging will be a little bit smaller. IKEA kind of, go to IKEA, pick it up off the shelf, and go home and install it, whether you live on a lodge or something else. So these are 2 flexi modules, flexible, very light in weight. The package will include the microinverter. So we'll have a package with the MP400 in it, the MS400 in it, and we'll have a package with 4 panels and an MS800 for the UK market. So quite exciting, really. So that's the vertical spider. Sits flush against the wall, and there is no excuse for anybody not to start taking part, as I keep saying. And this is what we call the pop-up, and that pop-up can go on the ground, flat roof, etc. We also got a product called Transformer, and the Transformer is what it says. Transformer can be bought without the panel, and it's got various functions. You can decide whether you want to put it on the wall, if you want to put it on a balcony, or you want to put it on the ground. So it'll do all 3. So I'll quickly go through this. Obviously, manage and monitor the panels. So we got apps that are different stages. Obviously, we've got a portal version, which is for the distributed installer. We've got a pro version, which is the installer and the end user, and then we've got the home app, which is only for the end user. With our version, obviously, we can do a lot more with distributed installer. We can actually update the system, change the country configurations, etc. So it'll give you obviously the generation data. It's very easy to connect onto that, and it'll give you the module level monitoring. Tower monitoring, this is for bigger systems. So basically, you can actually add this if you need, but the Wi-Fi is already built into the panels. So this MP3 is a power control device that will control power from various stages. So this is typically the MP, the external device. You can then really monitor what's been consumed, what's been generated, what's going to the grid, etc. So we also have power limitation products. This particular monitoring system can also do, if you need to limit the power, you can also use this to limit the power. So this could be on a commercial rooftop. Certainly, we're not allowed to export more than 100 kilowatts. We can obviously program these things to do that. And we obviously got other systems out there, which this is for our storage system. I haven't really gone through our storage system, so let's forget the storage system. Quick introduction to TSUN. TSUN's quite, the team goes back to 2009, and I joined the team in the early inverter days, the old team that was before TSUN was formed. Back in 2011, I joined them when they were known as Omnic Inverters, and the team is very well experienced. The product's always been great, and they've always been very, very thorough what they do. So we have a good management team across the board with sites to make sure that we have a global reach and get the product across the world. There's a lot more on the company side, but obviously the slides are not too much at this moment. But so we stop there because I could go forever on all of that stuff. We are appearing at various exhibitions. So solar storage down in Birmingham from the 17th to the 19th. So if you're anywhere near the vicinity, please do pop in and have a cup of coffee with us and have a chat about a lot more. I mean, I haven't covered half of the stuff that we know about what goes on as far as hazards are concerned in a PV system. By all means, pop by and then have a chat and we can discuss those. We will also be in other parts of the country. Don't know where that is, but so in I don't know where the country is. That Poland or somewhere, and then obviously Düsseldorf. I know where that is. We'll be in Düsseldorf the end of November. Thanks. Any questions? And I'll take those. All right, Luke, go ahead. I'll open you to the mic. Bear with me a second. I need to figure these things out before. Bear with me 1 second. Right, Luke. Go ahead, Luke. Ask away.
Suki, can you hear me?
Yeah, I can hear you.
Right, okay. A few questions, mate. For the Easy Kits, obviously they're plug and play solutions. So the plug, how do they work? Obviously on the AC cabling going back into the grid.
Yeah, as long as I mean, if it's just a single panel, you can put it onto the 13 amp main ring. So that's not a problem. The potential will just flare wherever it's needed. So the current will just go wherever it's needed in the system, whether it's a load or a load and go to the grid. So that just the ring will obviously be fed into the distribution board, I hope. But if you're going into 4 panels, then I would say I would suggest that the electrician brings in socket and directly into a fuse into the distribution board. So that would probably be the best for panel system. But 1 or 2 panels, 13 amp ring main, not a problem.
Yeah, perfect. Second question to obviously for the easy kits, can we have them balanced over the phases if they're hardwired into a 3-phase distribution board?
Absolutely. Well, yes, I mean, that's something we can design in. And if you want them phased in, then we can obviously help you out do that. Yeah.
So would that be separate systems per sort of like 1 microinverter per phase?
Absolutely. Yes. Then if you right now I'm doing a 1.2 megawatt system, which is huge, and it's going to take. We are putting in 250 ms 300s with 2 panels per MPPT, and that's yes. We are obviously splitting that per phase. We obviously one phase actually they use a lot more. Then we're going to obviously put design in enough power going into that phase, and then we can obviously take the other 2 phases as they want. So it can be designed the way you want it. So if a lot of offices, for example, phase 1 might be the primary phase that you use for everything, and then you might have phase 2 or 3 for other bits and pieces. But if you want more power going to phase 1, there's not a problem. We can design that in to the system. So this 1.2 megawatt system is basically, as I said, 50 odd inverters that we are using. I think 200. We're using about 150 on one phase, and the rest are split on the other 2 phases.
Got you. My third question, Suki. Obviously, for the microinverters have their own Wi-Fi built in. So there's no additional hardware you need for a small scale system. Because obviously, like competitors like Enphase, you've got to have their gateway.
That's right. Yeah. But for the bigger systems, I do hear the concern that a lot of people say, oh, if it's a huge system, we got 250 in this case, how are we going to manage the Wi-Fi? To be perfectly honest, I don't have the answer. I have asked that from the R&D department, so hopefully I'll get an answer. It's either very simple, because the accounts when you actually register your account, that's not going to be a problem to manage as many plants as you want. The generation plants could be, thousands of them if you want. But the question is now, when you got 250 Wi-Fi, what's the distance they will cover, and any other issues that might come into play, interference, etc. So those questions have been asked, and I hope that those will be answered real soon. So I'll let you know.
Perfect. That sort of wraps my questions up. Appreciate your time. Thank you, Suki.
No worries. Do you still want to have that call later on today, or are you okay?
Yes, if you don't mind, give me a call after when you're available.
Yeah, okay. I'll call you after lunch.
Fantastic. Great.
Right.
Thank you.
Thank you. Right. It seems like that we haven't got any other Q&As. Luke was the only one. Thanks for your questions, Luke. I appreciate that, and I'll give you a shout out later on. Any other questions? Nope. All right. I'll call it a day and let you guys go do what you all want to do. Thank you for your time. I appreciate it very much. And any questions, do reach out to us. You should have an email somewhere that will send to you. If not, then I'll make sure that somebody sends you an email with our details and give us a shout. All right. Thanks a lot. Thank you.